Oh, good morning, everyone. Can you hear me? Hello, we're going to get started. Thank you all so much for joining us. My name is Jim Fentner. I'm the Dean of Engineering here at NC State, and welcome to our first Applied AI in Engineering and Computer Science Symposium. The interest in today's symposium has kind of greatly exceeded our wildest expectations. You're going to see poster sessions, panel discussions, breakout sessions. We are going to be working today to hear from leaders, alumni, industry leaders, and we're going to be working to plan out the trajectory for this initiative for our College of Engineering and Computer Science and set the path for the next several years. I want to begin by just thanking our faculty symposium committee, Edgar Lobaton, the chair, Yara Yingling, Lirong Shang, and Muninder Singh, as well as our new director of Applied AI in Engineering and Computer Science, Aldo Dagnino. They've been working really hard to prepare for today, to plan out the agenda for the day, to coordinate with all the speakers. And I also want to take a moment and thank the staff support who's been just absolutely instrumental. Marisa Langford, as well as Bailey and Rose out front, and Tracy Brown have been super helpful in getting everything ready. Thank you all so much for that. And I'm looking forward to sharing a little bit about the vision for where we're going to go at the end of today. I'll be the last thing between you and happy hour. And thank you all for being here. And please join me in welcoming Edgar Lobaton to the podium to introduce our first speaker.
Thank you, Greg, and welcome everyone. Hope you guys are all ready for an exciting day of AI. So first, we're going to go over some logistics. So before introducing our first keynote speaker, I have a few announcements. If you register to attend one of the morning or afternoon breakout sessions, your session assignment is going to be on the back of your badge. So you haven't noticed that, it's highlighted in there. That includes basically the room location as well, too. If you do not have an assignment or need to make a change, please visit our registration desk on the front and on our next break as well, too. So what we're going to do now is we're going to go briefly over some key points related to the agenda, as you can see in here. So the detailed agenda is also on your table. You can also find it on the registration table right outside. Our keynote sessions as well as lunch will be here in this particular room. And then the upcoming poster sessions will be held in the common area right outside. That's when you're going to have an opportunity to talk to the researchers working on this project as well, too. and also be able to see what everyone is actually working on. So the breakout sessions will be held in this room, but they're also going to take place in some of the conference room in the 4th floor in this building as well, too, in the Han Library, and also in FWH right behind me. Right? Rooms are noted on the agenda, and there's also a signage out front, just in case you don't know where things are actually located. Great, so it is going to be my pleasure and my honor to be able to welcome Greg Mulholland, our first keynote speaker to the stage. Greg is a CEO and co-founder of Citrine Informatics, and is a recognized leader in the use of digital tools and digitization practices in the development of next-generation materials and chemical products, and the creation of next-generation business models in the industry. He has more than a dozen years of experience in the chemical, materials, and software industries, and has led functions across nearly every part of the business, including strategy, finance, marketing, business, and industry leadership. Greg has a Bachelor of Science in Electrical Engineering and a Bachelor of Science in Computer Engineering from NC State, a Master's of Philosophy in Material Science from Cambridge University, and an MBA from Stanford. Join me in welcoming Greg Mulholland.
Thank you very much, and it's a pleasure to be here. I always love coming back to NC State for many reasons, and I'm always shocked by the amount of change that has taken place since I've last been back. And I do make it back every 6 or 12 months, and so even to see how much the campus is growing and expanding, and now with students back, seeing the liveliness with all the students has been wonderful. I'm really excited to be here, and to be here among this group. I have met so many new faces, and also have had a chance to connect with some from my years at NC State, which I remember as fondly as one could possibly remember anything. I'm excited to share a little bit about what my vision is and what my thoughts are around AI, applied AI, specifically in engineering disciplines. And the reason I want to talk about this is because I believe it's fundamental to our future as a society that we bring these new tools into these disciplines that have for so long been relatively consistent. When I was being trained as an engineer, the lesson I learned maybe most clearly was we have a responsibility to be incredibly diligent about our analysis, to deliver things that are safe and effective for the world that uses them. And I'm seeing some nods around the room. I don't know that that's changed all that much, and I don't expect it to. But what was once a discipline of diligence and care that took a long time, the canonical engineering designing of a bridge we don't want to do that too quickly lest we make mistakes. That is changing. To start with, I think, at least when I learned it, probably know what this diagram is. I learned engineering as a linear discipline. I remember walking into E101 here at NC State my freshman year and being introduced to the Gantt chart. And James Peerless, NC State alum, who's on my team now at Citrine, can tell you that I regularly beat people up with these things. But they're a fundamentally linear way of thinking, right? You sort of lay out all the stages you need to go through. And that works pretty well if you can a priori think about and understand all of the steps that you will need to go through, no matter how many there are, to achieve the goal you're trying to achieve. Whether it's designing a new chemical reactor, working on a new material, designing a new transistor or computer system, bridge, whatever you are doing in your engineering discipline, if you get enough people together, you come up with all the stuff you have to do, you connect them with the lines, you figure out your milestones, done. You have engineered a thing, right? Absolutely not. But that is the pattern that we were taught in engineering, was to think about how all these pieces click together. The problem is, all the easy stuff is done. If we want to design a building or a bridge or an electrical system that's been designed before, that's relatively straightforward, right? You kind of copy it, you make the changes you need to make, and you a lot of times you'll simulate these things, and you figure out where you go next. But it's maybe a small iteration or maybe a relatively large wholesale copy of what you've done in the past with some small refinements. The problem is, if we are trying to deal with a very quickly changing world, whether it's, I had a good conversation with Marissa earlier around PFAS. We were talking about sort of the next generation of sustainability. We have energy challenges. We have pollution and carbon capture, and any number of safety issues with our infrastructure in the United States and abroad. And so if we think about the ways that we solve these problems and how we are preparing our students to solve these problems, it's not linear anymore. If it were linear, we probably would have already done it, right? If it's easy, well, I believe in us as professionals and in our broader engineering community enough to say if it's easy, we probably have done the thing already. So, what is the future of engineering? Well, I think given my title, the title of this symposium, and any number of other things, you know where I'm going with this, but I want to talk about why. In my view, the future of engineering is actually not single disciplines in engineering, which is one of the reasons I was so excited when Jim mentioned this center coming together, this effort coming together. And particularly, I want to think about it as an integrated discipline. Engineering is no longer, I do electrical stuff, and you do chemical stuff, and you do mechanical stuff. It is a world where things come together. How many of you have a smartphone? That's a shockingly small number, okay. So I'm going to assume that those of you who didn't raise your hands before paying attention, if you have a smartphone, you probably know that it wasn't a mechanical engineer that designed that thing, it wasn't an electrical engineer that designed that thing, it wasn't a computer scientist that designed that thing. And yet, without all of those people and many, many more, you can't have the smartphone, right? They all had to work together. That's a discrete system. But more and more, we need to think about systems that are much more complicated, that bring together many disciplines. And quite frankly, humans are sort of bad at that, right? Teamwork is this whole thing that we talk about, but collaboration, especially in technical disciplines, is all too often, I think about my really good idea and you think about yours, and then we debate each other at a conference, which is fine, but that's not the way we push the industry forward as efficiently as possible. I also think it means it's collaborative. It means we both bring our ideas, but we also seek to bring them together in a collaborative way, in a constructive way. It's multidisciplinary because there's all of these opportunities where a materials person can learn from a chemicals person, can learn from an electrical person, can learn from a mechanical engineer across the whole disparate set of engineering disciplines. None of us has, unfortunately, a long enough life to become expert in all of them. And I look forward, maybe, to the day where we do, though there are all kinds of ethical questions around that, but the idea of bringing these disciplines together is absolutely critical. And this is maybe the most contentious one. Engineering is a creative discipline. I still have very clear memories of sitting in Professor Mishra's office when I was an undergraduate researcher for her in 2004, I guess is when I started, thinking about how do we bring together these different materials to store charge in a DRAM capacitor. I remember it like it was yesterday. And it wasn't a strict technical discussion. There were technical aspects. We always technically vetted it. But it was spitballing. It was throwing out ideas about, well, why wouldn't we just do it this way? It's what makes engineering exciting, but it's also what causes us to learn to do the next thing. It helps us think about how do we break out of the boundaries that are currently imposed on us by the history of our thinking. And I'll get to the AI point in a moment. I want to add one more piece of context. So, a career, most people's careers are about 45 years long. This hasn't changed basically in modern history, post-World War II. Basically 45 years. You start working when you're 20-ish, you retire when you're 65, plus or minus 5 years. If you started your career in 1960, you had to manage one technology cycle. A technology cycle was 20 years long. So basically, you might have to manage two if you kind of hit the boundaries the right way, but that's a long time. So your career was, you came in, you dealt with some new stuff, you exploited that new stuff for most of the rest of your career, you became management, you made it somebody else's problem. Well, that's obviously not true anymore. So 1990, a period that was sort of relevant to me, though I was but a child, it was 10 years, right? So now you're managing, you kind of get through a couple before you become manager, make it somebody else's problem, but you do have moments of pause, you have moments of exploitation, you have moments where you can say, we made it through bringing in email, and now we're just going to use email before the next technology revolution comes. Well, I think you can see where this is going. I'm pretty predictable in these things. 2020, it's every 2 years. So rather than being, you've heard the saying, it's a marathon, not a sprint. Well, the first marathon, the 20-year marathon, it's a marathon. Second one, it's like a surgy marathon, right? It's sort of the Galloway method, if you know running. This 2020 it's a marathon, but it's actually a series of sprints punctuated by dry heaving, right? You're having to go, and you never get to rest. You just get to grab water on the side of the road and continue on. And the reason this is important is that when we teach our students and think about the future of education in our space, it isn't a world where we teach students one thing and then say, you know what, you can learn your next generation 20 years later in 20 years. Just learn it later. It's not my problem. You won't even remember who I was at that point. Now, before somebody goes from freshman year to senior year, and God forbid they choose to do graduate school where they go through even more, the technology landscape is changing under their feet 4, 5, 6, 7 times. Okay, if it's 7 times, you probably made some difficult career choices. But it's a really important thing to think about because we're not training students anymore to be an engineer that is going to just continue to execute like the engineers before them. It's someone who needs to adapt to new technology. And so what the future looks like, I don't know. I certainly hope that it continues to accelerate, but I also certainly hope that we can figure out how to manage that. How many of you have used ChatGPT or any of these AI tools? Great, okay, so those people who don't have smartphones are at least using ChatGPT. The interesting thing there is every 3 months, those models change fundamentally. They just announced one, James, what was it, 2 days ago? That's a chain of thought model that allows it to reason for the first time. It hasn't been put out into the world yet fully, you have to have special access, but it allows the model to do a lot more than it could even 2 months ago. And I think it's easy to forget that ChatGPT is not even 2 years old yet. So these things are moving in incredible ways. But it's totally changing the ground that we stand on. And this is where I want to move into AI. Now, what I will say is I will use the term AI, I will use the term ML. I'm going to use them interchangeably. Now, before anyone has a minor heart attack or stroke, I will say 2 things. The first is, if you talk to 100 people, experts in these fields in Silicon Valley about what the difference is, some will say one is bigger than the other, others will say it's the other way, other people will say they're entirely different. It doesn't really matter. And the second thing is, if you're focused on the definitional difference between AI and ML, you're probably getting passed by because of this. So I'm just gonna throw it out there, that's like my spicy take for the moment. It's important to understand what these tools are for, not sort of pedantic debate around what we name them. So I'll just use them interchangeably. In my view, what is happening in this space is absolutely amazing and in some ways utterly useless. So let's start with the amazing stuff, because who doesn't love to see some AI early in the morning? Some of you have probably seen some of these. Some of them are not public, so you'll get some more. Hopefully you'll be new. The first one is sort of flashy. I don't know if you've seen Sora, the OpenAI model. This came out maybe about 6 months ago, so I'm already out of date, but here we are. This was the prompt for this video was a flock of paper airplanes flutters through a dense jungle, weaving around trees as if they were migrating birds. Put that sentence in, you get this video. Extremely high resolution. I think we can all agree that that's pretty on target for what the description is, and it's actually quite lovely. If you go to their webpage, they have all kinds of these videos they generated. They're just phenomenal. Now, I will say, it is very unlikely that they have posted on their website 100% of the videos they've generated. If you've ever tried to generate a video using these tools, you probably know that it comes up with some crazy stuff, right? Like just absolute nonsense. I've spent a lot of time arguing with ChatGPT to create images, and I will tell you it's imperfect. But when it works, oh my God, does it work? It's just absolutely stunning. But is this useful? I mean, to someone, probably. In engineering, probably less so. I don't know how these planes are powered, but I'm certainly not getting on one myself. So, but I'm sure many of you have a need in your professional career, and certainly your students do, to create presentations, right? You give talks at conferences, you do this kind of thing. I didn't use this one. Whoop, I hit the wrong button. I didn't use this tool, but there's one called Tome. Generates slide decks for you. You can see the prompt. It was sort of generate something about a cloud hop, a sky bus service operating in the Bay Area. Generates a pitch, an investor pitch, including fake images about this flying bus service. It's absolutely wild. And this, you can start to imagine, where in this talk that I'm giving today, I could have typed in, I'm giving a talk at the Applied Engineering event at NC State, blah, 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 blah. Please generate me a slide deck. And it wouldn't have required me to take the time that it did to write this presentation. More importantly, and this is where it starts to be really, really critical, is it allows us to edit. And this is the thing I want you to hold in your head as you're thinking about the future of AI in these technical disciplines. Editing. I don't know if all of you have the same experience I do. But when I was in school, I'll use an example from when I was at NC State. I had to write my NSF GRF application. And I opened actually it was a PDF that you had to like paste a text into. It was kind of crazy the way we did things then. Blank sheet of paper. And I did the whole start with imagine, in the course of human events. How do you start these things? It's so frustrating. But now, I want to write a proposal about this thing. Help me write a proposal. It'll draft. ChatGPT will draft a proposal for you. And then, of course, you should edit it because both ethics and because you probably don't want to do whatever OpenAI just suggested. But it is a really, really powerful tool to make our lives easier. It's an incredible thing. So that's sort of a little closer to useful. But let's talk about robotics. Now, I know Edgar was telling me he works in robotics. This is an example of a robot. This robot has never seen this kitchen. I'm going to pause it for a second. Whoop. Nope, we'll come back to that. This robot has never seen this kitchen. We are going to tell it to go get a bag of chips from the drawer. Now, if this is a human, if I tell one person to go get a bag of chips from the drawer in a kitchen you've never seen, what you're going to do is you're going to walk over to a set of things that you know to be drawers. You're going to open the drawer. You're going to probably maybe get it wrong, maybe not, who knows. Pick up a bag of chips and carry it to me, right? Great, straightforward enough. What's interesting about this robot does that, having never seen the kitchen, right? This is in partnership with Google. And so it opens the drawer. Now, by the way, even that the LLM is giving it sort of the high-level commands and has other machine learning controls inside. It's going to reach in. It's going to grab these chips. But I want you to see what it does afterward. So it starts to be really interesting. So it grabs these in California. So there are these Thai rice chips. So, if you can't have a robot bring you a $10 bag of chips, what are you doing? So watch this. I didn't tell it to close the drawer. This robot learned manners. So for those of you in CS, I don't know if you still teach it this way, but when I was learning computer science in CS 101, I remember Jason Schwartz was my lecturer, and Jason said, to understand programming, you have to understand how programs interact with the world. So if you talk about driving to school, you can't just say drive to school. You have to say, you get in your car and you pull out of your driveway. You can't just say you pull out of your driveway. You have to say you put the car in reverse, you release the brake, you let the car move back, you slowly press the brake again. You have to be very pedantic with computers, right? They're not smart. They are processing systems only. And that's really, really important. But is that really true anymore? And I'll get to how we think about this, but I want to touch on one more, even more technical way of thinking about these tools. So this is work from Google. Google generated so Google has an AI system. Their sort of large language model proto generation is called Palm, and so that's sort of their GPT 3.5 by OpenAI. They created a version that was they created Flan Palm. Flan Palm was what they did is they took 1,400 facts about from an MCAT. They shoved it into this model, and they started asking it questions. And there's a canonical test that they will do in the medical field where they have a panel of doctors that they present a bunch of cases to, think like Dr. House style. I realize that's an old reference now, but you probably get it. They present a bunch of facts, and they see how quickly the doctor can get it and how accurately they can get it. Most doctors on this test, you can see at the bottom, 92.9%. By the way, these are not your experience at the doctor. These are doctors that are being tested, so they're not paying more attention to their insurance or the last case they saw. They're paying more attention to the actual test. So this is about as good as a clinician can do. Flan Palm, they shoved in a bunch of MCAT stuff, got it right 62% of the time. Okay, 1,400 facts. That's actually not that much. But, it's also not good enough. I'm not trusting my healthcare. Well, honestly, given my experience in the healthcare system, maybe I would. But in general, 62% not good enough. They then took 40 examples and hand-tuned them. Some were very simple examples. The boiling point of water is 212 degrees Fahrenheit. Some were much more challenging. this drug is used to treat this thing with these side effects. Very specific, but there were only 40 of them. I don't know about you, but I could probably generate 40 facts, deep technical facts about my discipline in like 3 hours, and that's with emails coming in and stuff, right? Like 40 is not that big a number. They use that to train this model. By the way, these are all just fine-tuning layers, so this takes like an hour. 92.6%. So the GPT-3 version of Google's thing, tuned with 1,440 facts, is now as good as a clinician taking a hard test. That's kind of bananas, right? These people train for years, and in some cases decades, and the ones that are being tested, I'm sure aren't the right out of med school ones. These are people with experience, who have reps, who understand this stuff. So in that case, what does a doctor do? Why do we even have doctors anymore if we can do this that well with computers? I think actually the real answer is liability, and we can talk about the legal profession and all this kind of stuff. There's a lot of liability questions in AI that will be very relevant to engineers. However, this is coming. Quick diagnosis through a doctor. You will still see a doctor, but now instead of them thinking real hard about what might be causing the itch on the bottom of your foot, they're going to take a picture, they're going to put it in this thing, and they're going to know pretty much for sure what the thing is very, very quickly. It's going to make healthcare much more efficient. It's going to fundamentally upend the balance of power in the healthcare system. And so the reason I wanted to start here was that engineering is going to go through a similar but extremely different set of changes as an industry and as a profession. We need to train our students to do that sort of thing, to understand these tools and use them collaboratively. Because the reality is, the problems that we face as a society are much too large to allow us to be static any longer. And we haven't been static over the last 20 years, but we are about to start moving a lot faster. And the students that are able to take advantage of those tools are the ones who are going to be successful. And the universities that bring these new technologies into their research endeavors and in their educational endeavors are the ones that are going to succeed. We are entering a new world of haves and have-nots. We are very fortunate at NC State to have been a have for a very long time, but it's our responsibility to continue to invest in the next generation of education such that we are able to take advantage of that again, to continue to be a have. I would love every university to have these capabilities, and I think they could be much more broadly applicable, or broadly available, I should say. But that does not mean that we will do it. The United States is not known for spreading things equally, and raising ourselves as a destination for this kind of thinking is actually a really huge opportunity to further elevate the visibility and credibility of NC State's engineering nationwide. And it starts from a very strong foundation. So, I want to talk about some actual engineering that we have done. Very briefly, I won't go into tremendous technical detail. By the way, I was not 100% sure how deep I needed to go in technical detail, so I'll have some time at the end for some questions, so happy to go into as much technical detail as I can at that time. But I will say, AI is already benefiting us in the engineering disciplines. I'll talk about some examples in my field. So by background, as Edgar mentioned, I studied first computer engineering and then electrical engineering here at NC State. I started in in processor design, which I realized was not my passion, but I still came to love it. You'll see that in a moment. And then moved into transistor design and sort of the more lower, more fundamental electrical engineering work. That's where I had an opportunity to work with Professor Misra. But then I realized these are all materials questions. Designing transistors, all these devices, there's a ton of materials limitations, and in a lot of ways, you're sort of trying to engineer around the fundamental limitations of these materials. And so I said, well, I want to understand these materials better. So I went and got a master's in material science, and then came back to Raleigh, actually worked at at an NC State spin-out in Raleigh called Kyma Technologies, making gallium nitride. I was growing crystalline gallium nitride, and I was shocked honestly. Because even at NC State, before this AI thing was a thing, before any of this, sort of fancy new computing, I always used computers. Right? I graduated in '07. Computers were like a real thing by this point. And we at Kaima were not really using computers for much of anything. They were email boxes and Excel boxes, and that was really it. And it felt to me like, given our runs and tests and all these things cost real money, tens or hundreds of thousands of dollars each, we were going to be in a place where we had good data and we needed to use that data. And so I was shocked that we weren't. And so during my time there, I've tried to bring in tools and realized this is actually really hard to do. And so I actually decided to go get my MBA, came out to Stanford, thinking I was leaving the materials industry behind, thinking I was leaving most of engineering behind. Candidly, I thought I was going to go manage supply chain at Apple or something, which a lot of friends who do that. It's a great job. But then I met a guy who had done his PhD specifically in machine learning for material science at Northwestern University. Specifically focused, by the way, on density functional theory, molecular dynamics. So for those of you who live in that world, you will know the major positives and negatives of focusing on DFT. And what I said to him was, Bryce, if you can make this work on real world data, I did not have a particularly high view of density functional theory at the time. And so I said, if you can make this work on real world data, we could have something really special here. We could help generate the next generation of sustainable materials and chemicals. And indeed, it worked. In the first summer of doing this work in business school, by the way, we published a paper out of the business school at Stanford, which is kind of wild, discovering a new class of thermoelectric materials, a crystal structure never before seen to exhibit thermoelectric properties. It was a nice demonstration of where this technology could go. And since then, we've had an opportunity to work in some really, really cool stuff. We've worked with some major chemical companies removing PFAS from adhesives and other, not just adhesives, plastics. PFAS is sort of in everything. We've had opportunities to work on lighter cars and planes, coming up with new lightweight alloys, high-strength ceramics, and even things like lighter polymers. Turns out it's like 10 or 15% of every car is just plastic. And so if you can make it lighter, you're actually making a pretty big impact. Or clean personal care products. It turns out almost every lotion you get on the market today has petroleum jelly in it. I don't know if I need to tell you, but petroleum jelly has petroleum derivatives in it. It is in the name. And most people don't want that these days, even though it is a quite good moisturizer and completely safe. Clean label is a target for so many of these personal care companies. And so what we've seen is across all of these domains, all of these companies are hungry to make better products, but don't want to take on the risk of a traditional years-long engineering process. So that's where Citrine comes in. This is not a marketing pitch for Citrine, but just to give you a sense of what we do, the problem that many engineering disciplines have is that our data is not free. So you may have heard of all of the debates around should Reddit close or open its sources to OpenAI? Should they get paid? What about New York Times? What about books? All these free sources of textual data that these machine learning systems, these LLMs, large language models, are learning from, it's really powerful stuff because they're able to go scrape the whole internet. Without the internet, none of this exists. Chemicals and materials, physical design, all of these engineering disciplines, to get real data, you have to build the thing, which in general costs money. And very often that data is extremely proprietary. Even government data, the government has all these open data initiatives, and I'll just say what they are. They're just hypocrites about it. Because if you go to NIST and you say, I'd like your data, they'll say, well, what are you going to use it for? Even if you can jump through all those hoops, it means it's not open data. If you have to open 5 gates for me to get access to it, it's not open, it's gated. You just happen to open them for me. And so you can't just say, I've got this OpenAI thing, and I'm going to dump all of engineering history into it, and now we're going to learn. We need to do things differently in our industry. And so what Citrine does is we couple the data that a company has with the knowledge of their experts. We call it domain knowledge integration. It is exactly what it sounds like. But a good example would be to say, if I'm making a new adhesive, and I'm a scientist who's been in the industry for 30 years, I might know that if I increase the molecular weight of a particular additive, the peel strength of the adhesive will go up. I just know that from my experience. I don't need 2-3 decades of data to tell me that. I just know it. I know these relationships exist. And then what I can do is layer the data on top to learn either the nature of those relationships, so actually apply numbers to the thing that I generally knew was true, or I can learn new relationships, which is even better, right? One of my favorite moments when someone using our platform, somebody using our technology, is when somebody says, oh, that makes sense. I never would have thought of it, but that relationship makes sense. Huh, I learned something new. It's really powerful when you have somebody who's like a deep expert admitting that a computer taught them something new. That wasn't possible several years ago, even 5-6 years ago. That was really when we were starting to make this possible. So being able to bring these technical disciplines together is really important. And you can imagine a world where it's not just this chemical knowledge, but my hope is that when we decide to design a new plane or a new car or a new consumer electronic device or whatever we need in the world, that we can have an integrated engineering flow where we're using AI at each step to take advantage of the computational data we have, the simulation tools we have. FEA is not going anywhere. Might be faster because of AI, but it's not going anywhere. The 3D design tools and the manufacturing optimization, so that instead of inventing a new material or a new product and thinking about it as this envelope that is sort of constructed in the human mind and then optimized for weight and then optimized for strength and then cost and then maybe sustainability in the future, we can use these computational tools to say, I need all of these characteristics, and I'm going to use this incredibly large lever that we have now and my own expertise to co-optimize all of those needs at once across the entire product lifecycle. I believe we're entering an era of mass customization, and I believe it's an incredible opportunity to elevate engineers from being sort of the people who work in the background. Like, let's be real. Most people can't name a single engineer who worked on your iPhone. The designer, at least until recently, you could name, was Johnny Ive, right? Like, he was the guy who made the thing. But there's a whole team of people working in the background. I actually think the next generation of engineers are the ones who start to get real credit for the work they do because they're starting to become the integrators of all these ideas. They become this high-level designer. And so this is what's exciting. I think it's a dawn of a new engineering discipline. Unfortunately, every dawn comes with a bit of a night before it. And I think we, in the current generation, the people who were trained in the old way, need to really strap on our thinking pants to make sure we can adapt ourselves and to help our students adapt too. So the question is then, in my view, is AI taking over? Or if you want the existential question, what's the point of it all? Like I do sometimes ask myself this, like if I used to need to be there to turn the engineering crank, but I'm not needed anymore, then are we headed in the direction of a Wall-E world, if you've ever seen that movie, where it's just like a bunch of people in floating wheelchairs kind of eating food and giving into marketing? Or are we headed into a world where we're each this incredible maestro, a conductor of new technologies to enable the future? And quite honestly, I think it's a personal decision and will be a personal decision for so many people over the coming years. Because if you are motivated to use these tools and you learn and you become part of the enabled engineering discipline, it's actually a truly exciting time. And if you just want to kind of harvest, I do think that possibility is there. Don't get me started on politics, but I do believe we're going to need to have some very serious, not job protection, but a fundamental reimagining of how we prepare society to live in this world, because I am not somebody who thinks that AI is going to dramatically increase the number of roles out there. I think it's going to be an incredibly, at least at the high end, competitive world for using these tools. The amount I can do personally on a daily basis, now that I'm using AI tools in basically everything I do, has probably quadrupled. There are people that I will never hire that I would have hired previously, simply because I can just get more done myself. But I don't think it's taking over taking over entirely. And here's where I want to touch on a bit of a computer science metaphor. So I mentioned I started in computer engineering, which gave me the at least trial by fire of understanding how we go from bits all the way to actual computer instructions and beyond. I am no expert in these things, but I at least had the introductory coursework. So I think everybody knows, processors run on binary, right? How many computer science and electrical engineering folks do we have in the room? Good number. So you all know this. This is great. So this start with binary, right? And the binary is annoying, right? Nobody really wants to write that. I mean, some people do it to be fancy, but let's face it, they're making bad life choices. So you at least go to assembly, right? Like you at least like do it in a way that a human can read it. You're going to use assembly. Okay, so we have an assembler that assembles from assembly to binary, right? Like I said, no one's going to write. Originally, somebody did. No one's going to write binary now. But actually, how many of you really write assembly code on any regular basis? Yeah, nobody. Oh, one person. Cool. All right, I'm so sorry. Then we get higher order languages, right? We've got C and a compiler. That was sort of my native language. There you go. And that's really good. You have good control. It's kind of a nice balance, though. You've got optimizers you can use or not use. It's great. But if you're writing C, you probably most times don't need to go write assembly, right? Your goals are at that C level. Well, now we've got Java, right? Java's an even higher level language that enables you to run on any processor. You've got the JVM. You've got all these tools. So you compile it, you optimize it, and now you're executing it in this environment that allows you to normalize across hardware. Also really powerful. And so if you are somebody who needs to write a program that works across many different platforms, you probably aren't going to waste the time to go write C and then compile it across every platform and get it to distribute it and then deal with all the distribution headaches when you can just jar up a Java file and send it to somebody and life is good, right? So these higher order things are really nice. And of course we have Python, which is sort of, I guess, in the middle somewhere. But we have all these new tools that are really powerful. And in my argument, AI is the next layer of abstraction in computer science. And it's going to be the next level of abstraction in many domains. I actually have a good mechanical engineering one I can talk about in a moment. But I think a lot of people see this as the opportunity to take jobs or the opportunity to sort of collapse what we need people to do. And I actually just see it as it's a power tool. It's a new layer in the tool chain that allows us to do the right thing, right? So if AI can help you write code, first of all, that's really nice. I don't know if anybody's used ChatGPT. It writes just killer Python. In fact, James knows this. There are a handful of people on my team who are very annoyed that I've started writing little scripts again and saying, hey, we should use this. It's really nice, actually. It makes me feel technical. Just feel. So it's an abstraction layer that allows us to do more and to not have to switch modes all the time. It's actually quite incredible. But it also doesn't take away our ability to use these other tools. So the other example I want to share, and I don't have a slide for this, but because a friend just told me this story. So one of my investors actually, his son is just finished his master's in mechanical engineering at Dartmouth College. And they have, and he was interested in AI. His dad's a VC in Silicon Valley, so he doesn't have a choice. And there was how many mechanical folks do we have in here? Okay, cool. So I can, you can tell me if this all checks out. There was a challenge issued by GE about a decade ago to replace this kind of crazy expensive bracket that they had in some of their aerospace parts. And they put it out to the academic community and a bunch of people, and there were all these different sort of optimizations, and I think they gave $1 million to the person who figured it out because it probably saved them 100x that. Mason, the son of my investor, took that problem, and this took months. I think it was like maybe over a year. He decided he wanted to see what could you do this challenge much more quickly now. And so what he did is he got a copy of ANSYS, he got a copy of one of the Dassault products, I think it was CATIA, but I'm not 100% sure, and he got a copy of a third design software. All 3D design with FEA simulators included, and he plugged an LLM, this is not technical stuff, just an LLM into these tools, and had it build an optimizer for each for a part in each of these tools. One of them was within a couple percent of the weight of the winning example from GE, but was cheaper. One of them was easier to manufacture and was also within a couple percent of the weight, and the third one was lighter than the winning submission from GE, though incredibly expensive. That's cool, right? That's a pretty cool thing. He's, what, 23, and he's doing what took this engineering sort of competition a year to do. He did it in 2 hours. That's wild. It's absolutely crazy. He did it on his laptop. And so when we think about these things, what that does is it doesn't mean we don't need bracket designers anymore. It doesn't mean we don't need mechanical engineers. And by God, I really hope somebody tests that thing physically before I ever get on one of those planes. But what's really powerful is it took his time and compressed the rote work of actually drawing these things out and testing ideas and allowed him to be at the helm of an incredibly powerful ship that could carry him to where he wanted to go. That is what these tools are going to enable us to do. I actually see the opportunity, the bright opportunity, and by the way, if you catch me on 5 different days, I go like this about whether AI is the end of humanity or the savior. It's sort of whose hands do you put it in and how effective are they using it? But today I'm in the positive zone, so I will say AI actually allows us to have the best of both worlds. Human knowledge is the starting point for all this stuff. We need expertise in our domains. We need business understanding. I don't know if you've asked ChatGPT business questions, but it's like, I have a relatively, I got my MBA. I have relatively dim view of like MBA strategy. I think there's a lot of like empty shirt syndrome in that discipline, but there is some really good thinking, and ChatGPT is really good at making a lot more empty shirts. So as humans, we need to think about what are our trade-offs? How do we think creatively? How do we grow what we're trying to do and expand the area that we're trying to operate in? And by the way, I am not a fan of putting complete control in the hands of an AI. I have lots of opinions and thoughts around self-driving labs, so if anybody wants to have a robust debate around that, we can go find a room that's well insulated, we could shout. But it's, I'm just kidding, I love them. But the opportunity is really huge. At the same time, AI is good at a lot of stuff that the rest of us aren't good at. Optimizing many things at once, explaining itself. There's this whole idea of explainable AI. That's actually really powerful. Here's the problem. Most humans are actually really bad at explaining stuff. So I guarantee you there are things in your discipline where you're like, no, this is just how it is. And you might not even really be able to off the cuff explain why, simply because you're an expert in the field. I know I do it all the time. It's kind of what mansplaining is in a lot of ways, except sometimes there's no expertise behind it. So that's a really important thing, is that these AIs can build up their own knowledge and then explain to us why they did things so we can validate them, even in spite of the fact that the bar should be lower than it maybe is when we compare it to humans. They're often unbiased. Now, I want to be really careful here. I'm talking about engineering AI. I want my bridge building model, my jet engine model, my materials model to be biased as hell. Because scientific bias is, in general, correct. It is saying, I want it to be, this plastic, I'm going to bias the plastic model against polluting materials. I'm going to bias it in favor of a better tensile strength model, whatever the thing is. Bias, lowercase b bias, can be useful in these highly technical models. Anything related to humans, money, business, actual decision making, bias is toxic and terrible, and we need to really watch out for it. But in engineering models, domain knowledge integration is sort of the way we pre-bias a model in the formal sense. And so I do want us to be careful about unbiased, there's some trickiness there in terms of linguistics. And it can learn from a huge volume of data where we have it. So if NIST or the Army Corps of Engineers or whomever decides to open up data sets in some safe way, we can learn from all those things in a way that would be impossible for a room 1,000 times the size of this room to jointly learn from. It's just too much information. So I'll get to the end here, and then we have a few minutes for questions if you'd like. So I talked a little about today's students. For a long time, innovation was seen as invention. How many of you have gone through the whole like patent disclosure process at NC State? I know a few. So that was innovation, right? Like, if you talk to the CTO of a company, we're inventing new stuff. I don't actually think that's true anymore. And I don't think that's how we should be building our students, teaching our students to think about it. Because we are in uncharted waters. I don't know where AI is going, and neither does anyone else. And anybody in this room or anywhere else that says they do is flat lying to either themselves or everybody else, or both. Because if you ask Andrew Ng, Jeff Hinton, Eric Schmidt, all of these people have been wrong in the last 12 months about AI in one major way or another. In some cases, it's done way more than they said. In some cases, it's done way less. The reality is we just don't know. And there's a lot of technical reasons we don't know, but some of it is related to this emergent phenomenon of when you train for long enough, you see these discontinuous improvements in AI models. Now, what is an improvement? Who knows? But in my view, innovation is about learning. The way we overcome that 20-year cycle turning into a 2-year cycle is by teaching students to be aware, to see the whole field, to understand how they can learn new things. Because this generation, and even every generation I see in this room, does not have the luxury to say, I don't need to learn the new thing. I'm too close to retirement. Because as long as you're more than 2 years from retirement, you have to learn the new thing. And so this is an opportunity. And I will say, this is, I made this slide before anything political happened. I actually think SpaceX is a really good example. If you're a Boeing stan, I'm sorry, Boeing put a ton of money into one launch and it didn't go so well. SpaceX crashed this thing over and over and over again, but you know what? It is now, every time, getting to the space station. It's a powerful thing. And so our goal as a team in bringing these students together and teaching them to be the next generation of leaders is about how do we teach them to learn faster, to grow more, to become masters of their own destiny, rather than thinking about it as a chunk of technical knowledge that we shove into their brains and hope they use in the future. Our job is done. Because our palette today is bigger than ever before. We can control things down to the atomic scale. We can design these crazy parts and produce them by 3D printing in a way that we've never been able to do before, and humans really have a hard time conceiving of. And so this knowledge, it requires adaptation. It requires us to learn and grow alongside the tool so we can use it as effectively as possible. So thank you very much for your time. I'm an optimist. I believe the future of AI is a bright one for us, but only if we can teach people to accept it and be smart and think critically. Because if we just let these tools overrun our professional lives, we're going to find ourselves lost in a sea of things happening too quickly for us to even understand what's happening to us. And so I believe we have an opportunity at NC State to train this next generation of leaders, and I'm very, very thankful for the opportunity to be here and share with you all.
Thank you very much, Greg. So we have time for maybe 1 or 2 questions. If anybody has a question, please raise your hand. We have somebody with a mic over there. They're gonna come to you. I think there's 2 questions on the table. And of course, Greg is gonna stay here as well too after this session, so you'll be able to talk to him afterwards. But let's start with the questions, sir.
I have the mic. Should I pass it on? I got one. Okay. So, did he really do it on his laptop, or did he do it on his laptop and a large collection of GPUs run somewhere else? I mean, there's sort of an image of, I sat down with my laptop and did it, but the reality is there's a massive infrastructure behind that, including lots and lots of money and time. I mean, so how does that work, and how does that work if everybody's just dependent on the same infrastructure to scale?
Yeah. So my understanding, and I have only spent a little time digging into the details, is the engineering simulations were on his laptop. The LLM calls were to cloud LLM services. I think he was using Anthropic, but yeah, I mean, I think there's certainly the privacy and security questions around this stuff are all, especially for these shared models, are all huge questions. It's getting clearer. You can gain access to private models, but I think it's the training primarily that is sort of the massive investment, right? You know, that's kind of the big piece. The queries are getting better, but
Was that part patented? Did the model perhaps train on Boeing's patent on the gene's patent on the original work?
I couldn't say. It's certainly possible. Yeah, I mean, the models are sort of well known to have read patent literature, so yeah, certainly possible.
There was another question, I think. Yeah, on there.
Hi, good morning. Thank you for your presentation. You said right at the outset that linear thinking in engineering is sort of passé, right? And I submit that linear thinking is actually required for nonlinear, what I call nonlinear thinking. So what's your opinion on that?
Yeah, I mean, I think it's no one wins an Olympic medal by crawling. Yet we all had to crawl to be able to walk, to be able to run. And I think it's very much the same thing. I think we need to teach people to be linear thinkers. I think, honestly, most people are pretty good linear thinkers. And I would submit that the goal of an engineering education, where when I learned early, it was very linear and like a doubling down on linearity, or maybe, you know, superposition of many linear lines. But I think we need to quickly get through the linear thinking and start helping students get to nonlinear thinking faster. But yeah, it has value. It's just, it is now part of the foundation as opposed to the top level.
Monitor? Okay. And
Hey,
these
Greg,
two, and then we'll stop it right there. But go ahead.
Yeah, thanks for your nice talk. I thought, you know, this idea, so imagine that we have AI, something that'll do anything we wanted it to do. I think if you go back thousands of years in like Indian and Middle Eastern and Chinese cultures, you'll find that they're replete with stories about somebody asking for something and getting exactly what they asked for, but which was exactly not what they wanted, right? And I think in an engineering standpoint, there's this old sort of notion of systems engineering. You know, in computer science, we used to talk about requirements elicitation, and then, you know, going all the way on to the validation and redoing. And I think somehow our students are never too excited about that, but maybe AI will force us to bring that back, like put an emphasis on understanding requirements, put an emphasis on validation, and then even if the machine does a lot of the work, we have something to stand for.
Yeah, I mean, I think that's the hope. You know, the joy, the terrible thing about working in materials is a lot of the stuff we do is not related to, you can't like buy it. Right, like it's way up the supply chain and ultimately, but there are some products that we work on that you can buy in Home Depot. We work on like bits and blades and things, and to see the joy on my team's face, when like, I helped make this. This is so cool. I want to help engineers get there. Like, I don't want to just have them understand theoretically what is a transformer, what are windings, how does this whole thing work. I want them to be able to think, I helped to create this system that powers our world. And I think sometimes, just in the nature of the job, we get so close to technical details that it's, I know I have at some points lost inspiration in my own field because I've lost the thread about where we're going. And I think AI has the opportunity to help us not remove, but smash down a little bit the time we have to take to create to go through these engineering processes. And we can focus more on the big picture orchestration and the systems engineering, as you said, of creating the thing that's actually transformational. That's not to say there isn't lower level transformational stuff, but you want to do the lower level transformational stuff and then get it out into the, you know, into the world in a really fundamental way. And that's what excites me. And I think AI opens the door to help students accelerate that pathway in a way that heretofore was very, very difficult.
Thank you, Greg. So yesterday, NC State had a wellness day, which we've been using to essentially take some of the stress off of students. When you introduced that tech cycle, where now, you know, we're proposing 2 years now, potentially months in the future, how do faculty keep up with advances in technology? How do they channel that to the students? But also thinking back to that idea of wellness days and stress, how do we make sure that people trying to keep up are not burning out?
Yeah, I'll let you know when I have an answer to that one. You know, I mean, I think, look, what I have tried to do in my own life, because, you know, ostensibly I am in a field that is sort of moving at least that fast, probably even faster at this point, given that we work in AI. In some ways, it's a little bit freeing, but once you get over the sort of mental barrier, right? I don't know how many of you have spent any time on boats, but if you ever get on a small boat, you're kind of doing one of these all the time. And then at some point you're like, oh yeah, the boat's just moving, and my knees have figured out how to just sort of deal with it, right? And my shoulders can stay straight, and as long as I don't go over the edge, I'm good. I think we need to teach students to operate in the world a little bit more like that. I think this idea of you develop expertise and you plant and build your life on that expertise for the rest of your life is simply incorrect. It's just not going to play out well over the next 50 years. I think we need to teach students to be okay with uncertainty, to be okay with your sort of figuring out how you're going to kind of adapt along the way. And what I've, I get approached by students a lot, especially NC State students actually, about, what advice do you have for me as a professional? And my advice is always, don't focus on the job you get. Focus on being the best in the world at whatever you're doing. And I can just see, like when I say that to somebody, they're like, oh, okay, so I don't have to go work at Google. I don't have to go work at Apple. I don't have to go work at Wolfspeed or whatever the places they're really excited about. I can go work at a place that might feel better for me at a particular time and just be really excellent there. And I think the technology, the way of thinking about next generation technologies needs to be sort of the same. How do we enable a student to say, I don't like this tech, I'm gonna focus on the next one, I'm gonna try to learn continuously and integrate new ideas. I think it's in some ways an opening up of the technology landscape for people to use whatever tools they feel most comfortable with and can have the most effect with. And there will be people, rather than making one big career bet, in my view, are going to be making hundreds of smaller career bets, which I'm no portfolio theorist, but I understand that to be a better bet in general and lead to better outcomes. However, I actually think the mental health challenges are going to be larger on all of you than on the students. Because I think I got an iPhone when I graduated with my master's. So it was 2008. I remember I got this, the iPhone 3G was the one that I got. And I was so excited. I was 22 years old. These people, some of these students that are at school now, at NC State now, have had a smart device on them since basically they could use one, right? You were talking maybe 10, maybe it wasn't, at 4, but they are used to these things. They're used to changing technology. They're used to seeing all this sort of new era. And so I think the bigger question is, rather than creating, I've taught courses, I've seen many of you teach courses, where you sort of create content and then you sort of teach the same thing for the majority, 5, 10, 12 years. That works if you're doing fundamental stuff. But if you're trying to teach at the highest levels and trying to encourage students at the highest levels, it's that plus how do I think about these problems for when I encounter stuff that's totally new 6 months from now. And that's, I think some of us came away with that, frankly, in undergrad. Certainly everybody didn't. And I think it's incumbent on NC State as a university to figure out how to do that more and more, because adaptive students are going to be the best students. So I realize I've taken all of my time. Thank you all very much.
Thank you. Thanks, Greg, again.